Hello everyone, welcome to Starting from Zero. So in this video we are going to see about rolling. So rolling is one of the very important chapter in the manufacturing, which comes in the under the chapter of the metal forming. So I can say that 95% of the chances are there that only numerical questions will come from this chapter rolling. So in this video we are going to see all the important concepts, all the important formulas which are required to solve any kind of questions coming in the exam related to rolling. So we can say maximum benefit with minimum time and with minimum effort, right? So let's start this chapter. So first of all, here we are seeing, here is a metal strip and here is a roller. So rolling means there is basically two rollers, and between which a metal strip is passing and which is just reducing its height. So its initial height was h0 and its final height will become hf. So whenever it is passing through it, it is converting its height from h0 to hf. So this is what the main process or the actual process of rolling is, right? So here r is the diameter of the roller, h0 is the initial height of the metal strip, and hf is the final height, right? We can say the initial velocity of the metal strip was v0, and we know that the velocity of the roller, let's assume it as fr, and the final velocity will become hf, where alpha is a bite angle, okay, which is angle between this radius and that end point where it is touching the roller. So this angle is alpha. Alpha is a bite angle which is generally given in radian, right? So remember this. Now very important thing is the forward slip. So if in question there is a very little chance that question will come from forward slip and backward slip, but still you have to remember this, that forward slip is equals to vf, that is the final velocity minus the initial velocity divided by the final velocity into 100%. If it in percentage it is asking, then simply multiply it with 100%. And in case of the backward slip, the formula is Vr minus V naught by Vr into 100%. So if you want, you can remember this, but there is very less chance that questions will come from this, but still you can remember, so that if any questions come from backward slip and forward slip, you can solve it with ease, right? Now the next important formula, which is the most important formula, and I can say that every time whenever questions are coming from rolling, this formula will come in use directly or indirectly, right? So you have to remember this formula. This is the most important formula of this chapter, that is a del h, which equals to d, that is the diameter of the roller, into 1 minus cos alpha, but del h is the total reduction in height. I have just said that the initial height was h0 and the final height will become hf. So del h is nothing but h0 minus hf. So it is given by the formula, that is the d into 1 minus cos alpha, where d is the dia of the roller, alpha is the bite angle, which is given in radian. If in question it is given in degree, then you have to convert it with multiplying it into pi by 180 degree, 180, right? So this is very important formula, you have to remember this. Then the next thing is the LP, right? So this is LP, that is the deformation zone or deforming zone, or I can say it is the length of the arc, right? So this also comes in exam very often, that is LP is equals to root under r, that is the radius of the roller, into del h. So from here we can find del h, or del h will be simply h0 minus hf, right? If h0 and hf is not given, then you have to use this formula, and if it is given, then you can directly write del h equals to h0 minus hf. So that is LP will be equals to root over r del h. So this is also one of the very important formula, you have to remember this to solve any kind of questions, right? And this is also very important formula. All the formulas which I am writing is very important. Many times questions are seen from these formulas directly or indirectly, right? So del H max is nothing but the maximum possible draft in the rolling operation, which means it is the reduction in one pass, that is the maximum possible reduction occurs or can be done in one single pass, right? In one single pass means in one time. That is the it is when it is passing through this roller in one time. So in one time, the maximum possible reduction which can be made is that del H max, which is equals to mu into r square, where r is, we know that it is the radius of the roller, and mu is the coefficient of the friction, right? So it will be generally given in the question. You have to just put it, and radius will be also given, and del H max will be mu into r square. Please remember this. These are very important. And the next formula is the Neap angle. It is not very important, but still if you want, you can remember this. That is, Neap angle will be just simply 2 twice the mu, that is the coefficient of friction, which will comes in radian. And if in question it is asked in degree, so you have to just convert it by multiplying 180 by pi, right? So that it will convert in degree. So this is not very important, but still you can remember this, that Neap angle will be equals to 2 into mu, right? Now the next formula is the most important formula. Every time, I mean many times, questions are seen from this. That is the power in rolling. You will be simply given all the datas, all the velocities, all the height, and you will be asked to find that what is the power in the rolling. Okay, so you don't have to mug up all the formulas, just remember the procedure, right? Just remember the derivation. It is not very lengthy derivation. You have to just remember that how to find, right? So we know that power is equals to torque into omega, right? But here, as two rollers are used in rolling, so the power will be 2 into torque into omega, right? So next thing is how to find the torque. We know that torque T equals to force into distance, and omega is the angular velocity, and we know it is 2 pi n by 60, where n is the rpm of the roller. So this thing is clear to you. This is easy. And torque equals to force into distance, right? Now just remember that distance here is the a, which is the arm length, right? So what is arm length? Just remember that arm length equals to lambda into lp. Okay, where lp we already seen that it is the in length of the arc, or you can say the length of the deformed zone. So we know that its formula is root over r del h. So this is already seen. And lambda is the arm factor, which is either 0.3 or 0.4. If in question it is given that it is a case of cold rolling, then use 0.4. If it is given that this rolling is a hot rolling, then use 0.4, right? If nothing is mentioned that it is hot or cold, always take it, or always consider is hot rolling, so therefore the lambda value will be 0.4. Okay, so this is known, and this is you can also find. And F is the roll separating force, right? So you have to remember what is how to find the roll separating force. It is simply F equals to 2 by root 3 into sigma y, where sigma y is the average flow strength. Average flow strength is unit is Newton per meter millimeter square, or meter square, where B is the width. B is the width of the plate. B is the width of the plate. I am writing here width of strip, I can say. It will be generally given in the question. And LP, we have already seen what is LP, right? That is the length of the arc, and in bracket 1 plus mu LP divided by 4 into h average, where h average is nothing but the initial velocity, that is the average of the height, that is the initial velocity plus final velocity divided by 2. If sigma y is not directly given, sigma y is the average flow strength, then definitely the sigma f, that is the sigma flow strength, and back flow stress will be given. You have to just simply find the average of the flow stress and the back flow strength. So generally it is given, that is the average flow strength is directly given in the question. So you can simply put all the values, and then you can find the roll separating force. So this is very easy. If you just practice it once or twice, you can easily find the formula of the power, and you can easily solve, and you can get the answer very easily, right? So just remember the main formula, that is power equals to 2 into torque into omega. And remember that what is the formula of torque, what is the angular velocity, how to find it, we already know this, that is torque equals to force into distance. Only just remember that here distance equals to lambda into LP, and we have to remember that how to find arm factor, that is cold rolling, hot rolling, this thing we have to know. And the most important is the role separating force. We have to remember this formula. This is quite difficult to remember. If you practice 2 to 3 times, you will easily remember this. So this is all about rolling, and if you practice it, if you remember all this formula, you will be able to or you will be in a position to solve 90 to 95% questions coming in the exam related to numerical problems. This is not, I have not discussed anything about the theoretical questions, because very less chance is there for the theoretical question to come in the competitive exams like GATE, engineering services. So this will be more than enough for you to solve any kind of numerical questions. So that is all about rolling, which is a very important chapter in the metal forming, right? So thank you for today, and please subscribe this channel, because as there are very less number of subscriber. And if you have any request, if you have any doubt related to any other topic, you can also comment, in the comment section, and I will definitely try to clear your doubt, right? And if you like this video, please like it and please subscribe. Okay, so thank you for today.